Hello everyone, my name is Nibol Kir and today I'm going to be giving a presentation on foundation computing. Firstly, we're going to talk about the CPU, its functions, and its components. So what exactly is the CPU? CPU stands for Central Processing Unit, and it's a chip made up of very many microscopic transistors that can be found in the motherboard of your computer. The CPU is said to be like the brain of your computer because of the many functions it carries out, and the speed at which it operates is measured in a unit called hertz. So now we're going to talk about the components of the CPU. So the CPU is made up of many components, but the ones we're going to talk about are the memory storage unit, the control unit, the ALU, the arithmetic logic unit. We're going to talk about the registers, the cache, the buses, and the clock. So these are again the internal components. So what are the functions of the different components of the CPU? The memory storage unit is a unit that stores data, instructions, and results from the CPU, and it gives information to the other units of the CPU as needed. And then all the inputs and outputs in the CPU pass through this. The control unit, it controls the transfer of data and instructions, and it manages all the units of a computer, but it does not process or store any data. The ALU, which is the arithmetic logic unit, it's made up of two parts, the arithmetic section and the logic section. The arithmetic section performs arithmetic operations like adding, dividing, subtracting, and multiplying. And the logic section performs all logic operations like selecting and merging data. The registers, these are small high-speed memory, and they store small amounts of data that are used in processing. The different registers serve different purposes, and each register usually has the following: a program counter, a memory address register, a memory data register, a current data register, and an accumulator. The cache is a small high-speed random access memory, RAM, and it temporarily holds data and instructions that the processor may reuse. The buses are a type of high-speed connection, and it's used to send control signals and data between the processor and other components of the CPU. The three types of buses are the address bus, the data bus, and the control bus. Next, we have the clock, which coordinates all of the CPU's components. It gives out a regular electric pulse that keeps all the components in sync with one another. The speed at which it operates is measured in a unit called hertz. The CPU has four main functions, which is to fetch instructions from the memory, decode the instructions into binary code that it can then read and understand in order to carry it out, execute, carry out what it was instructed to do, and store, which is like storing feedback in the memory. The computer hardware components, we're going to talk about that. So these are the basic computer hardware components. We have the CPU, which is again the brain of the computer. We have the peripherals. These are things like the keyboard, the mouse, sound systems, etc. Then we have buses, which are, we talked about them, high-speed internal connection used for sending data to the other components. And we also talked about the three types. So how the different components of the CPU work together. The mouse and keyboard are used to input data into the computer. Next, we have the peripherals, which are connected to the CPU by the address and data buses. Then we have the buses. They allow the CPU to point out where the data is, and they can request that data be sent back for processing or storing. Then we have the CPU and its four functions. And then we have the output devices like sound speakers and printers, and they store the information in physical form or audio. Next, we're going to talk about storage media. The different types of storage media, the two types we're going to talk about are primary and secondary. So primary storage devices, these are internal volatile memory. Volatile means that it's short term. Examples of these are RAM, random access memory. It allows for a user to perform different tasks on the computer. The cache, it's high-speed RAM that stores information for future use. And the ROM, which is read-only memory, it allows the user to only read and write, meaning that changes cannot be made to the document or the information. The secondary storage devices, they can be internal or external non-volatile memory. Non-volatile meaning that it is long-term. Examples of these, we have hard disk drives, HDD. It's a form of a magnetic disk, and it's written top and bottom. So again, can be used internally or externally. We have SSD, solid state drives. It's a storage device that uses flash memory and can be used internally or externally. The advantage of this is that it's fast compared to the HDD, and also it consumes less power. The compact disk drive, this is a portable disk that saves audio, video, and other data for later use. The USB storage device, I think this is something that we are all familiar with. It's a drive used for backup of data for future use. It's external and then is input into the computer. Other types of storage devices, we have flash memory devices. So they are long-term and non-volatile. Examples, we have the memory card and the memory stick. We have optical storage devices. They use light and lasers to get and store information. Examples of this, we have the Blu-ray disc and the CD-ROM disc. Then we have the magnetic storage devices. They use magnetics to view, write, and display information. Some examples of these are the hard drive and the cassette tape. Next, we're going to talk about data in computer systems. So how is data represented in computer systems? It's represented using 4 number systems. We have the binary system, the decimal system, the octal system, and the hexadecimal system. So the binary system is also known as base 2. It uses the numbers 1 and 0, so 1 representing on and 0 representing off. The decimal system is also known as base 10. It uses 10 digits 0 to 9 to represent data. The octal system is also known as base 8. It uses 8 digits, numbers 0 to 7. And the hexadecimal system is also known as base 16. It uses 10 digits, numbers 0 to 9, and 6 letters, letters A to F, to represent data. Next, we're going to talk about encryption. So what is encryption and why is it important? Encryption is the process of taking plain text and mixing it up into an unreadable format called ciphertext. So basically scrambling up the text. It keeps the information confidential for the user only. So what is the importance of data encryption? It's important because it secures information and data, meaning that anyone that is not allowed to access this information will not get access to it. So even if an authorized person gains access to it, they will not be able to read the information until they decrypt it. So how encryption can be used to represent data? So data that is encrypted using the American Standard Code, it's a chart made up of many characters such as the decimal, hexadecimal, HTML, and description. And then we have the Unicode. It's code that's able to support popular and special characters such as Mandarin and Japanese, as compared to the American Standard Code that might not support these languages and these characters. So the 2 types of encryption, we have symmetric encryption and asymmetric encryption. So symmetric encryption, in this type of encryption, the same key is used to encrypt and decrypt data. So an advantage of this is that it is fast and convenient. Some examples, we have the hard drives, we have flash disks, we have CDs, we have the RSA, it's a type of encryption algorithm. We have the DES, triple DES, and the AES. The problem with this type of encryption is that if the information is being sent on the internet, it's possible for a third party to intervene, as they can hack into the computer and find the key. The asymmetric encryption, in this type of encryption, a public-private key is generated. So the public key is visible to the public, but the information can only be decrypted with the corresponding private key. The advantage of this is that it's more secure than the symmetric encryption. especially when the information is being shared on the internet. Some examples of this are the RSA and the SSL. So now we're going to talk about popular encryption algorithms. We have the RSA, was formed by three mathematicians, Rivest, Shamir, and Edelman. It uses the factorization of two large prime numbers, and only a person with the knowledge of these two large prime numbers can decrypt the message. Triple DES, it's symmetric, yeah, and it was created to success the original data encryption standard DES after hackers broke into it. It applies the DES algorithm to every data block 3 times, and it's mostly used in the ATM pins and the Unix passwords. The AES, it uses 192 and 256 bit keys for encryption. It's used by the US government and other big organizations. Next, we have Blowfish. It breaks down messages into 64-bit blocks and then individually encrypts each one. It's mostly used in e-commerce platforms for securing payments and password management. Next, we have Twofish. It encrypts data in 16 rounds and is used in file and folder encryption. Next, we have FPE. It's new, fairly new, and is used to preserve the structure of data after it has been encrypted. So now we're going to talk about how images and sounds are represented in computer systems. The way images are represented in computer systems is by using the binary number system. So the computer uses the on and off techniques of binary numbers to create pixels, like representing like 1 and 0. And the pictures can be in black and white, but also color. The way sounds are represented in computer systems is by using the same binary number system. So sound is input into the computer using a microphone. Then the sound waves from these sounds are converted into a digital signal. Then that digital signal are then converted into binary and then recorded to the nearest whole number. So now we're going to talk about encryption applications. So we have hashes and digital certificates. So hashes, they generate a series of numbers and characters that make sure information is not corrupted. And then digital certificates, these are certificates that are given by a third-party company that vouches for the website so that users know it is authentic. So usually when you visit a website, you can look at the digital certificate and see if this is a proper website or maybe it's a scam. So now we're going to talk about the encryption protocols. So we have the Internet Protocol Security. It's a framework for different types of encryption, and it verifies using a private public key. The point-to-point tunneling protocol, it was developed by Microsoft and other tech companies, and it makes sure the connection between the VPN user and the VPN network are secure and running smoothly. Next, we have the Layer 2 tunneling protocol. It encloses network data twice, and it works with the Internet Protocol Security to provide secure connection and encryption. Next, we have the Secure Socket Tunneling Protocol. It secures the connection between the VPN client and the VPN server. Next, we have the Secure Socket Layer, and it connects with the web server, and it also provides data encryption, message integrity using certificates, and authentication during encryption and decryption. Next, we have the HTTPS, Hypertext Transfer Protocol Secure. It's a mixture of HTTPS plus SSL, which is the secure socket layer, and it protects against online theft of information. So now we're going to talk about data compression. So what is it? It's a process of encoding data to reduce its size. This kind of reduction is only possible if the original database contains some type of redundancy. The two types of data compression we're going to talk about are lossy compression and lossless compression. So lossy compression, it works by finding the patterns and repetition in the data. The index words in the data are then replaced by numerical values. The index needs to be stored with the data to allow decompression to occur without any data loss. So it's used mostly in PNG, GIF, and zip files. Lossless compression, it's a compression algorithm that permanently removes data from the file that the computer is able to compress without redundant data. So once that lossless compression is done, the file cannot be returned to its original state and quality. This allows to create very small file sizes, and it's mostly used in MP3, MP4, and JPEG. So how can compression aid in the storage of data, images, or sounds? So it allows for the data, images, and sounds to be stored in the smallest size possible while still keeping the highest quality possible. And then another thing, large files, they take long to upload and download from the internet. So when compressed, it allows the files to be made smaller and allows for easier uploading and downloading from the internet. Now we're going to talk about logic gates and their purposes. So what are logic gates? They're the building blocks of digital systems, and they allow us to make complicated decisions based on simple yes and no questions. They are made up of 2 inputs and 1 output. Logic gates, for them to work, require a power supply, and there's always a time delay in input being processed and output given. So what is the purpose of logic gates? They're used for a number of reasons. They're used in many things. So a number of electronic devices like the safety thermostat and the push button lock, they use logic gates, and they're also used to perform complex logical functions. So now we're going to talk about inputs and outputs. Inputs, these are voltage with 2 nominal values. They're always on the left side of the logic gate, and they represent 0 and 1 respectively. Outputs are voltage with 2 nominal values, and they're always on the right side of the logic gate. They cannot be connected to each other and should be connected to inputs, and again they represent logic 0 and 1 respectively. And only one output is there, except in some special cases. So now we're going to talk about truth tables. It's a table that's constructed for a logic gate equation that shows all the possible inputs and outputs for that gate. So the number 1 in a truth table is used to represent high input or high output. The number 0 is used to represent a low input or low output. So digital circuitry. So what is a digital circuit? It's one that processes simple yes and no questions according to the different logic gates. So the 2 types of logic circuits that we're going to talk about are combinational logic and sequential logic. So what is combinational logic? It's a type of circuit that's made up by a combination of logic gates, such as the NAND gate. So we have the NAND gate or the NOR gate, and then they can produce 1 or more outputs. This is not dependent on past inputs, so like the outputs are not dependent on past inputs. Next we have sequential logic. It's a type of binary circuit, and it consists of 1 or more inputs and 1 or more outputs. It's dependent on clock cycles, and it is dependent on past inputs as compared to the combinational logic. It's a type of circuit made up of blocks of combinational logic, and the memory elements that separate these blocks are activated by a clock signal. So now we're going to talk about the different types of logic gates. So the NAND gate is a combination of the NOT and the AND gates, and it's an AND gate followed by a NOT gate. So in this type of logic gate, the low inputs equals high outputs. Next we have the NOR gate. It's a combination of the NOT and the OR gates, and then high inputs equals low outputs. Some special gates we have, these are known as the exclusive gates. It means that the inputs has to be exclusively 1 or 0. So we have the XOR gate. It's exclusively OR. So the output is high if either of the both inputs cannot be high. And then we have the XNOR gate. So it's exclusively OR. It's the opposite of the XOR gate. And then the output is low if either of of its inputs are high, but both inputs cannot be high. Next, we have the AND gate. It's a circuit whose output is high if its inputs are high. We have the OR gate. It's a logic gate whose output is high if either or both of its inputs are high. Next, we have the NOT gate. It acts as a switch and produces the opposite of what was initially input. If the output is high, the NOT gate will produce a low output. Next, we're going to talk about computer networks. So what are computer networks? They are networks made up of a group of computers or like devices connected together, and they are linked together to share resources and to communicate. These are linked through telephone lines, cable, satellites, and radio waves. So what are the components of a network? A network is made up of a number of things such as servers, clients, media, shared data, shared printers and other peripherals, and resources. So servers, these are computers that give resources to network users. Clients are the computers that access the shared resources provided by the servers. The media, these are wires for physical connections. Shared data are the files or documents provided to the clients. Shared printers and other peripherals, there are any other resources that are provided by the servers. The resources, we have the printers, scanners, files that can be used by the members of the network. So now we're going to talk about the types of computer networks and purposes. The two main computer networks are peer-to-peer and client-server network. So what is peer-to-peer? Peer-to-peer is a communication model in which each involved party has the same responsibilities. So they can act as a client and a server. So what is it mainly used for? It's mainly used for privately routing network traffic, parallel computing environments. It's used for storage, media sharing, software piracy, and software violation. It allows members to control a number of things, as a number of people that can be connected, which services to provide, and which systems to connect to. So what are the advantages and disadvantages of peer-to-peer? Advantages are it's easy to set up. All the partners can be clients and servers. It's cheaper. There's no need for professionals to monitor the network. There's no need for a dedicated server to be a computer or dedicated computer to be a server. Disadvantages are it's not very secure. It's time consuming because each computer network needs to be applied. The network security needs to be applied and backup performed separately for each computer. There's no specific server to control and manage the access to data, and passwords have to be separate for each computer. Also, unsecure passwords can allow easy access to computers by unauthorized persons, and it's really difficult to recover the data. Next, we have the client-server network. It's designed to give clients access to information and files such as music through a main server, like here. Powerful computers are dedicated to managing disk drive file servers, printers, print servers, and network traffic, network servers. Clients are PCs on where users can run applications, and they rely on servers to access resources. Each network can either be a client or a server as compared to the P2P, but not both. So what are the advantages and disadvantages of client-server networks? The advantages are there is a main administration that controls the network. The management of files is easy because they're all in the same space. Backup is possible because information is stored on the server. There is strong security. Information can be accessed from different devices because it's all in one place. The disadvantages are that it can easily become too congested due to many requests, which can sometimes lead to the failure of servers. If a server fails, the whole network goes down, and it's expensive to start up. It needs professionals to manage and set up. So now we're going to talk about hardware used in computer networks. So we have network cables, basically the cables. We have routers. They make it possible to connect to different networks together, and it can create a LAN. Next, we have the repeaters, objects that increase the strength of a single connection without losing its quality. Next, we have the hubs. They transmit data to the other devices on the network. We have switches. They store MAC addresses of devices and filters data packets to the appropriate devices. We have the bridges. They connect two separate LAN networks, and they only send a message after having found the receiving device. Next, we have the bridges. No, next we have the gateways. It's a kind of router that creates a passage between two networks. And then we have the NICs, the network interface cards. They're small circuit boards that are connected to the motherboard and allow desktop and laptop users to connect to a network. Next, we have the firewalls. They're a type of network security that manages the traffic and analyzes for scams, viruses, or content from suspicious sources. Then it decides whether to allow or block this content. Next, we're going to talk about software used in computer networks. We have the Network Operating System, NOS. It's an operating system that's designed to support workstations, database sharing, and file sharing, among other things. Some examples of this, we have the Microsoft Windows Server and the Mac OS X. Next, we have the Local Area Network Software, LAN. This kind of software allows the user to monitor all the devices, such as servers and printers on the local network. Examples of this, we have home Wi-Fi and small business networks. Next, we have the local operating system. It allows personal computers to be accessed devices such as printers and files on a computer. Examples, we have the Apple iOS and the Google Android OS. So transmission media using computer hardware. We have guided media. We have the twisted pair cable. It's made of copper wires twisted in pairs and it's mostly used in telecommunication. We have the coaxial cable. It's made of copper or aluminium and wrapped by an insulating layer. It's used for work sites for local areas and cable television. Next, we have the optical fiber cable. It's glass fiber that carries light that represents data. Next, we have the terrestrial microwave. It uses earth-based transmitters and receivers resembling satellite dishes. We also have the communication satellites. They communicate through micro radio waves. We have the cellular and PCS systems. They use radio and communication technologies. We have the radio and spectrum technologies. They use high frequency radio technology. And then we have this free space optical communication. It uses light for communication, so both visible and invisible light. So now we're going to talk about the World Wide Web technologies. There are web pages found on a network and can be accessed on the internet. The three types of worldwide technology protocols that were created by Berners-Lee, they are the Hypertext Markup Language, HTML, Uniform Resource Locator, URL, Hypertext Transfer Protocol, HTTP. So the HTML is a language made up of special codes that creates pages on the web. It allows for content such as writing and images to be seen on a web page. The URL, these are the addresses for the web pages, and they must be used to gain access to these pages. Then we have the HTTP. It's a protocol that uses a client-server model to connect together web pages. It's used to transfer HTML documents and other information over the internet. So now we're going to talk about the OSI model. So it's a type of framework that describes the functions of networking systems. It puts together computer functions into a set of universal rules on how to support connections between different products and software. The 7 layers of the OSI model are, we have the physical layer, which is responsible for sending raw data bits from the physical layer of sending device to the physical layer of the receiving device. We have the data link layer. It's node-to-node data transmission that's performed by very close together nodes. We have the network layer. It receives frames from the data link layer and delivers to the destinations according to the addresses in the frame. We have the transport layer. It's in charge of delivery and checking for errors. We have the session layer. It controls the conversations between computers. We have the presentation layer. It translates data into language that the application can understand or that it accepts. We have the application layer. It allows the end user and application to interact directly with one another. So now we're going to talk about computer network topology. So this is how computer networks are connected and how information is passed around. It shows how networks are arranged and connected. And the word topology refers to the layout of connected devices. The devices in the network are called nodes. So we're going to talk about the different types of computer network topology. We have star topology, in which all the nodes are connected to a centralized hub, and then all the hub acts as a switch for the nodes. Data does not pass through every node, and then also the hub broadcasts the message. Next, we have bus topology. It's There's a common bus used for communication and a one transmission line for all the nodes. The message sent can be heard by all the computers, but only the receiver can accept it. So all the other computers deny it. The So the bus is sent in one direction, and once that message is received, that data is then deleted. We have tree topology, in which all the nodes are connected to a main hub directly or indirectly. It's a combination of bus and star topology, and it allows for easy maintenance of the subhubs. Next, we have mesh topology. All the nodes are interconnected with each other, forming a type of mesh. The nodes are able to directly communicate with one another, and the two types of mesh are full mesh and partial mesh. Next, we have ring topology. So each computer is connected to two other computers in this kind of topology, and the nodes are connected in a closed loop. The way it works is in a type of token-based system. So each computer is given access to a token within a time interval. Next, we have the hybrid topology. It's a combination of two or more topologies, and it allows for the best features of each topology to be used. Now we're going to talk about network protocols. So what are network protocols? They're a set of rules that determine how data is passed along through different devices connected in the same network. Types of protocols. We have the IPv4. It's a 32-bit IP processing protocol. We have the IPv6. It's a 128-bit IP addressing protocol. The HTTP is for transferring hypertext from one system to another. The SMTP, it sends and distributes outgoing emails. The POP is in charge of receiving incoming emails. The FTP, it allows for the transfer of files from one device to another. The TLS and the SSL, they use encryption to protect the transfer of data and information. So that brings us to the end of our presentation. And these are the sources.